Let's review the method of half reactions. First, we break the overall equation into two half reactions. Then we balance everything but H and O. Then we balance the oxygens by adding water as needed. Then we balance hydrogens by adding hydrogen ion as needed, assuming we are in acidic solution. Then we add electrons as needed and multiply each half reaction by integers to cancel the electrons. Step 3, we're going to add the two half reactions and simplify. And step 4, if we're in basic solution, we now need to add enough hydroxide ion to cancel any hydrogen ion and simplify again. Let's balance this reaction, which takes place in basic solution. In an earlier lesson, we did an example of balancing by the method of half reactions in acidic solution. I think it's time we do one in basic solution. I've copied the steps that we need to go through and put them here in the upper right so that we can see how this works. Step 1 says break the overall equation into two half reactions. We see here in the equation that we have some cyanide ion, carbon, nitrogen, and on the product side we have this ion, which also has carbon and nitrogen. So I think that's a good first step for one of the half reactions. And the other half reaction, we've got the permanganate ion and then MnO2 on the product side. So step 1 I think is done. Let's go on to step 2. Part A says balance everything but H and O. One carbon, one carbon, one nitrogen, one nitrogen. Okay, that's balanced. Everything except H and O. Manganese, manganese. Oh, that was an easy one. How about 2B? Balance oxygens by adding water as needed. So in the top half reaction, we're going to need one water on that side. And in the bottom half reaction, we're going to need two waters. This makes sure that the oxygen atoms are balanced. The next step is balance hydrogens by adding H plus as needed. Well, the top half reaction on the reactant side has two hydrogens, so I think we better add 2 to the product side. And the bottom half reaction has 4 hydrogens on the product side, so we need to put 4 hydrogens on the reactant side. So that step is now done. Next, we need to add electrons as needed, such that the total charge on each side is the same. In this top half reaction, the net charge here, hopefully you can see, is 1 minus, and over on the product side, the net charge is 1 plus, because we have 1 minus there, and 2 pluses, so the net charge is 1 plus. Reactant side, 1 minus. On the product side, 1 plus. Where would we put electrons, and how many, such that the charge on each side is the same? And hopefully you can see that we're going to need 2 electrons on the product side. That will make the net charge -1 for both the reactants and the products in this top half reaction. Now, as I mentioned in an earlier lesson, if we put electrons on, say, the product side for one of the half reactions, we are expecting to put electrons on the reactant side for the other one. If we find ourselves putting electrons on the same side for both half reactions, we're doing it wrong. Let's make sure what we have here. For the bottom half reaction, on the right, we have a net charge of 0, and on the left, we have a net charge of 3 plus. The permanganate is 1 minus, 4 hydrogen ions, so that's a net charge of 3 plus. Where would we put electrons, and how many, such that somehow we can make 3 plus equal to 0? I'm thinking 3 electrons on that side. So step 2D is now done. Okay, step 2E. Multiply each half reaction by integers to cancel the electrons. Here we have 2 electrons in this half reaction, and we have 3 electrons in this half reaction. Hopefully you can see that what we're going to need to do is multiply this entire top half reaction by 3 and the entire bottom half reaction by 2. So let's do that. We're going to change 1 water into 3, 1 cyanide into 3, one of those ions into 3 of them, multiply the hydrogen ion by 3, multiply the electrons by 3. Now for the bottom half reaction, we're going to multiply that whole thing through by 2. We're going to change 3 electrons to 6, 4 hydrogen ions to 8. We're going to make that 2 permanganates, 2 manganese dioxide, or manganese 4 oxide, either one is okay. And we're going to make that 4 waters. Electrons now cancel. I'm going to cross them off. 6 electrons there, 6 electrons there. Step 2e is all finished, which leads us to step number 3. Add the 2 half reactions and simplify. So let's see what we have here. It looks like we've got 3 waters on the reactant side, and then we have 4 waters, you can see, on the product side. That leaves us with a net of 1 water on the product side. Similarly, we have 8 hydrogen ions on the reactant side and 6 hydrogen ions on the product side. That leaves us with a net of 2 on the reactant side. I don't think anything else cancels. Let's see what we have here. There we have the 3 cyanides and the 2 permanganates, and on the product side 3 CNO- and 2 MnO2. That equation is balanced. You can check the atoms balance, the charge balances. That is the right answer if we were in acidic solution. But it very clearly in the upper left states that this reaction takes place in basic solution. So now we need to go on to step 4, which says add enough OH to cancel any H+. So what we're going to do is put 2 OHs on each side, because this equation is now balanced. So whatever we do to one side, we have to do to the other. Now 2 H pluses plus 2 OH minuses yield 2 waters. And now let's simplify again. We have 2 waters on the reactant side and 1 water on the product side. That leaves us with a net of 1 water on the reactant side, in addition to the 3 cyanides and the 2 permanganates. On the product side, we have 3 different species, and we're done.